Hi folks, and welcome back. So today we're going to talk about how to add vectors together when we have situations where the vectors are either parallel to each other or perpendicular to each other. Now, these vectors could be displacement vectors, they could be force vectors, they could be velocities, they could be all sorts of things. But I think the easiest way to kind of visualize and understand what we're doing is to talk about it in terms of distances or displacements. All right, so I'm going to use that as the example just to give us a nice visual, and then we'll work from there. All right, so in this first one here, you can see it says walks 20 feet blank, then goes 10 feet blank. And it says how far and what direction are they from their origin. So I want to talk about a few what if scenarios. So let's say, for example, that the person starts out by going 12 feet east, 20 feet east, excuse me, and then 10 feet also east. And it says, how far and what direction are they from their origin? So you probably already know the answer, pretty straightforward, right? If we go 20 feet in an east direction and then we go 10 feet in an east direction, we're just going to add those numbers together and we're going to get 30 feet east. And that's all we need to do for that. So when the two directions are the same, then we just add the numbers together. Pretty straightforward with that. Now, let's imagine that we change it up a little bit. What if the person walks 20 feet east and then they go 10 feet to the west? All right, so what do you think you're going to do in this situation? How are we going to get the answer? We know that east and west are opposites of each other. So if you go 20 feet to the east, then 10 feet in the opposite direction back towards the west, essentially what we're going to do is subtract these numbers. All right, so we have 20 feet east minus 10 feet west. We're going to end up with 10 feet. And because the east is the bigger of the two, we're going to end up 10 feet east of our starting point. So when the vectors are in opposite directions, we're going to end up subtracting them. All right, so we subtract the numbers rather than add in that scenario. Okay, and then the third case would be if they're at right angles to each other. Well, the third case that we're going to talk about today, that is. So if I undo this. So let's imagine now instead of 10 feet, 20 feet east, then 10 feet west, let's say 20 feet east and then 10 feet north. And the question is, how far and what direction are they from their origin? All right, so this is definitely a little bit more tricky case. We're not going to simply add 20 plus 10. They're not 30 feet from their starting point. If you tried something like this and you went 20 feet to the east and 10 feet to the north and walked back, you would notice that you're not 30 feet away from the starting point. All right, so the answer is not 30, and it's definitely not 10 either. So in this case, because they're at right angles to each other, we can kind of visualize this almost like a right triangle. And we're going to use the Pythagorean theorem to figure out how far. And we can also use some trigonometry to help us find the direction of that displacement. So I'm going to use another slide and we'll draw it out on the next slide. Okay, so we have 20 feet to the east. So I'm going to draw that like this. So we have 20 feet this way. And then we're going 10 feet to the north. I'll use a different color here. Like this. Should be a 10. Okay, and we want to know, well, we started here and we ended up over there. How far and what direction are we from the starting point? Well, since these are perpendicular to each other, they're at a right angle to each other. Let's draw that in here. They make a 90-degree angle. What we can do is connect them with a line, starting at the tail of this vector and going towards the tip of that vector. So we draw a line in this direction. And we learned from the Pythagorean theorem that to get the hypotenuse, the long side, of a right triangle, we can take the sum of the squares of the sides. So we square this, we add them together, we take the square root. That will give us our total displacement, which we call the resultant. All right, so let's call this R for the resultant. Okay, now if you remember from the Pythagorean theorem, we could say 20 feet squared plus 10 feet squared equals R squared. Okay, so 20 squared, that's 400. Let's clean that up a little bit. Plus 10 squared, which is 100, equals R squared. So R squared equals 500. So R is going to be the square root of 500. All right, so let's see what that is. So we'll punch it in the calculator. Whoops, push the wrong button there. Let's do that. 22.36. So you'll notice it's bigger than 20 and it's bigger than 10. Units are feet, just like the other two. So we squared the one side, we squared the other side, added them together, took the square root. That's how we get that. All right, so that tells us how far. We also need to know what direction. All right, so imagine getting this angle right here. Let's find what this angle is. I'm going to draw the symbol theta. So what we can do to get that angle is we can say that theta equals the inverse tangent. Now, if you've never done sines, cosines, and tangents before, it's something that you will learn as we go a little bit further along in the course and in your math courses as well. But the tangent of an angle is just the opposite side over the adjacent side. So if this is the angle, this is my opposite side, this is my adjacent side. So I'm going to go the inverse tangent. I write that like this. And we go opposite side, which is 10 feet, over the adjacent side, which is 20 feet. Okay, now, before we do this, an important note. When you put this into your calculator, first of all, to get the inverse tangent, you need to hit the second button on your calculator. You'll notice that your calculator has a button for sine, cosine, and tangent, and then above it, it says inverse sine, inverse cosine, inverse tangent. We want to make sure that we're using that inverse function, so hit the second button when you do it. The other thing that's important here is you need to make sure that your calculator is in the proper mode. It needs to be in degree mode. When you're using your calculator, if you've never played with the mode button, by default, if you're using a TI-83 or a TI-84, they are in what we call radians. Okay, we need to switch that to degrees in order to do the calculations. So you hit the mode button, and the third option down says radian or degree. You want to put it in degrees. Okay, so we switch that over, and then we can actually do this calculation. All right, so I'm going to set that up and do it as well. So I'm going to do inverse tangent. Let's see. Inverse tangent. Oops, I got to clear out the other thing. Inverse tangent of 10 over 20. All right, I get 26.6 degrees. So the angle is 26.6 degrees. Okay, so if you look, our answer is this blue vector here. It is 22.36 feet at 26.6 degrees. And if you think about it, this black line was east. So that is 26.6 degrees north of east. So when I write my answer, I'm going to write 22.36 feet, and I'll write at 26.6 degrees north of east. So I'm able to use the Pythagorean theorem to tell me how far. I'm able to use the inverse tangent to tell us what direction. That's how we're going to do it when we have them at right angles like this. Okay. So to summarize, if you have two vectors that are in the same direction, what you're going to do is just add them together. If they're in opposite directions, then you subtract. And when they're at right angles, you're going to use the Pythagorean theorem, really, and inverse tangent. I should probably add that in there. And, oops, inverse tangent. And we didn't do an example of this, but if you have more than two vectors, which we won't see a whole lot of, what you want to do is combine all the north and south, like group them all together first, group all the east and west together first, and then use the Pythagorean theorem like we did in the example here in the video. So that is how we do addition of vectors when we have parallel vectors or perpendicular vectors.